Welcome to Groundwater Talk Live. We had a little glitch here going live on LinkedIn, but we are here with Ed Schofield of Johnson Screens, and Ed's going to enlighten us on a lot of topics. We're probably going to have to go to a part two at some point because I think we got a lot of ground to cover, but Ed is probably the most experienced guy I know with water well construction and design, and more recently, well rehab is where he's at now for Johnson Screens, but he's been there for 36 years. So let me bring Ed on, and if I can get my cursor here. All right, Ed, welcome to the show.
All right. How are we today?
Doing good, doing good. Let me turn your
Thanks for having me on. I really appreciate that. With that introduction, I may not be able to get back through the office door. So,
yeah. Well, you certainly are, a very knowledgeable guy, and one of the ones I go to, reliably when I have well questions, and you always have answers. So give us a little background on yourself. I know you've been in the business, mostly with Johnson Screens for over 36 years now. So that's a lot of experience.
Well, I got lucky in that my parents got a divorce when I was in high school, and I'd always been told I was going to high school, but I went to an ag and engineering school because it was the least expensive school that was out there, and as a result, I got an opportunity to get an internship with Getty Oil, which is now Texaco and Exxon. But that particular opportunity that got me out in the patch, got me out of the office and got me into the patch, working on a pulling rig, was a game changer for me. I just found something that I absolutely loved. I was pretty good at it and understanding what was going on, and so graduated with a business degree, minor in mechanical engineering, and then went to work for Baker Hughes. And my sole, interview was, have you done anything in the patch? And I said, yeah, I've spent a couple of summers working on a derrick. And they said, let me see your hands. And I had all my digits. And as a result, I got the job from that moment on. So I spent almost 9 years straight working offshore, Gulf of Mexico, Alaska, and possibly one of the best experiences one could ask for in regards to prepping yourself for understanding what's all involved. A service company, Baker Hughes at that time, was involved in the acidizing, the fracking, the cementing, and the gravel packing, which is where I obviously came into contact with Johnson Screens. And then from all that, Johnson offered me an opportunity when 1988 rolled around, and there was basically a kibosh on any future well drilling activities throughout the West Coast. So I came on, tried to go and handle, and we were successful in taking care of both the oil and gas work on the screen side. So continued with my offshore endeavors, but also got a chance to go and see water wells and how they're completed, and learned a tremendous amount, but was also able to share simply because back in 2007, I was asked if I would be a McElhaney speaker, one of the guest lecturers for the National Groundwater Association. And my topic was oil and gas, they really should mix, or water and oil, they really should mix. And it was basically taking a look over the fence, seeing what operators are doing in the oil field and what we can, in fact, start utilizing for completion practices and drilling practices here in the water well industry. And it's just evolved. It's just basically allowed itself to metamorphose into, what are we trying to do? How can we be more responsive? How can we utilize the materials? Some of the shortages we're having, some of the changes in materials that we're having, into best applications, best practices for putting together a completion and trying to go and get the best bang for the buck, because ultimately that's what we've got, is a reputation we got to keep. We've got to go and get the customer the best possible completion, and however that comes into play is whatever we can possibly do to put that entire package together and deliver a competent well. So
you bring up an interesting point, and before we dive into the questions, I know back in COVID, our COVID past, we were having some real supply chain shortages. Have those been resolved, or are we still seeing some? I mean, we're seeing, I mean, in the Middle East, we're seeing the Houthis attacking ships in the Red Sea, and different things around the world where we're seeing supply chain shortages. Is that affecting the water well industry still, or have those things been resolved?
There's still a lot of issues. I don't know if there was ever a game changer in the industry like COVID, or even for our society. I mean, had it not been for Wi-Fi and the ability for us to work remotely, I think our economy would have been in shambles. But yeah, we still rely an awful lot on foreign source materials, and that, as a result, some of them are not good players, some of them are not good partners, and we certainly have transportation and supply chain issues. So yeah, costs have come down, transportation, logistic timing is improved, but we're still seeing latent hangovers from all of that. And so you have to anticipate. And that's one of the things I constantly harp on. And that is, if you're unsure, make sure you've got everything on a job site before you start your completion. Because waiting on one thing, and it could be an O, it could be a spline, it'll hold that whole job up. So we got to make sure that we've got everything prepared. And to answer your question, no, we're still not out of it. There are still lingering hangovers from that. And I'm not sure when it's ever going to be the way it was before. Certainly our employee basis and such. And it's just an interesting change. The entire market was turned upside down, and we're just slowly but righting the ship.
Interesting. I did a show, it's probably been a little over a year now, on pre-designing water wells to kind of get around, kind of when we were in the height of supply chain issues,
Yeah.
and really more just from the standpoint of trying to getting things ordered in time, and I'm sure that's something that they work with Johnson Screens on is getting all
With
that
everybody.
stuff and understanding where we are with supply chain issues and what kind of lead times we're looking at. But anticipate that. Don't just, it's not like going down to Walmart and picking something up.
Well, you're finding empty shelves or different material than you did a few years ago. There's a wholesale shakeup, but the absolute truth is getting material on the job site and assuring yourself. I mean, going through the entire checklist, and I'm going to be a huge proponent of talking about checklists and outlines and preparing, because it takes that one thing. The experience that we've garnished over the years is that it takes one thing to go ahead and throw a wrench in a completion, and that can easily cost us a competent completion or time and money. So yeah, making sure everything's ready to go and double check is inherently the best possible practice that we can have at this point.
Yeah, exactly. So, with that, let's kind of dive in a little bit, because we started talking about best practices, but what do you see as best practices in water well design and then I guess construction too? And where do people tend to run into problems, and what are some best practices that people can implement when they're looking to design and construct a new, and mainly focused on municipal type water wells, because that's mainly what we do is those types of things, and just discuss what you see out there and what you recommend as best practices there.
Well, I mean, experience is possibly the best possible opportunity. Taking a look at what there is existing from an infrastructure standpoint, from an operational well standpoint. Have we in fact had failures of a given nature? What's the water chemistry like that we're looking at? Have there been changes in that water chemistry? I mean, we have seismic events out here, and we can have wholesale changes in regards to the amount of CO2 and other gases and stuff, simply because fractures open up, and all of a sudden we've got very corrosive water, where 6 months ago that was never an issue. So experience looking at what is existing, what are the complications and the problems, what worked, what didn't work, and get those compiled. Taking a history of what the operations have been will give us kind of a roadmap as to what we'll be looking at moving forward. And the follow-up to any and all of that is just, your well design comes down to what kind of corrosive water, what kind of depths, what are the forces we're going to see. Are we going to be fighting some sand? If we are, how bad is it, and is it in fact something that was been managed before, or we're going to have to take extra steps? So looking back oftentimes gives us a really good indication of moving forward in regards to what we need. And again, it comes down to an experience level, it comes down to a confidence of the records and the history of what we've got to basically, look at, cite that new well, and whether or not we're going to have an opportunity of working on a postage stamp. I mean, there's no free range or free ground any longer that we can go ahead and set up on. So we're going to have to be anticipating very small facilities, very small setups. What's the logistics going to be? There's just a whole lot of groundwork that needs to be done before you can ever get yourself in a situation where you say, yeah, I've got it. I know exactly what I need. You're going to have to do some homework and know exactly what has been done, the good, the bad, and the ugly, before you can go ahead and really put a good plan together.
So Johnson Screens does speaking of best practices, they do produce the book on best practices, Groundwater and Wells, which is in its third edition. Yeah, although I'm a fan, I do have to admit I'm a fan of the second edition. It's a kind of the classic, but there's a lot of good information in the third edition too.
We tried to cut that down so it wasn't quite so meaty, but a lot of people who use that book, a lot of people would slice that book up. It was their vehicle copy, their truck copy, and then their office copy. So yeah. But someday we'll put it on a digital format. But for those of you who aren't familiar, the Groundwater and Wells is kind of the Bible. And if you're not familiar with well drilling practices, maybe not even reading the whole thing, but just the glossary in the back is invaluable to new people. And we're very proud of that book, and it has been a mainstay for a lot of folks getting their feet wet in this industry, or a backup if by chance things don't go quite as well as they had hoped in the field.
Yeah, I mean, there's more knowledge in there than you can possibly stuff in your head. So it's really highly recommended that I use both the second and the third edition because oh man, I'm drawing a blank on his name. The author of the original edition,
Fletcher Driscoll. He was a giant, but he had many people in a room that helped him and assisted him in a tremendous amount of, again, experience. Yeah. And I will also tell someone, do not give that second edition away, because I think I recently saw on eBay that it's going for close to $1,000. So it's out of print, and don't let anybody borrow it.
You'll never get it back if people borrow it. So
it's up on eBay.
If you really need money, you can throw it on eBay and pick up a quick $1,000. Yeah. So no, I know. I've got a couple copies here, and I'm keeping it. I'll hand them down to when as part of my inheritance.
There you go.
All right. So what are some common mistakes you see from people out there, when they get into the design and construction? I mean, we see a lot of different things, but from your standpoint, you probably get these frantic phone calls from people that have, messed up, or, I don't quite want to put it like that, but where they've probably not done things quite right for their situation, and and you might want to address the topic that every well is an individual, just like a person. Every well is an individual, so one size fits all approach is not the best way to design a well. You need to understand. So
I mean, I'm, like you said, 36 years with Johnson. I've outlived a lot of wells that I helped design, and I'm not proud of that fact, because I'll use an example of a very well-known hotel in Las Vegas that had a very sizable investment going into a water feature out front that is still well-known and still used in all kinds of backdrops for Hollywood movies. And I was in that meeting and dealing with the project managers on that particular project, and they were going to go with low-carbon steel. And I went, wait a minute, guys, you realize that you're spending millions of dollars on this surface facility. Why are you going with low-carbon steel on the well construction? Oh, it's just a well. Oh, okay. So they drilled 4 wells.
Just a well,
forward, Fast forward 25 years later, I had a consultant come up at the National Groundwater in December in Las Vegas, and he started browbeating. He goes, I cannot believe you let them drill low carbon steel completions for that particular prospect or that hotel. And I went, oh, no, I was Khrushchev. I was in the back. I had my shoe off. I was banging on the table. But dang if I didn't outlive those 4 wells. They lasted 25 years, as we would typically give. So the parallel or the lesson from that is we can anticipate, but in this industry, there is an awful lot of people that have this mentality is it's fine as long as it outlives me in my retirement. You know, as long as I get that well in, I keep it under budget and can satisfactorily go and say that it'll last until I retire, I'm done. And that's a mindset that has to change. I mean, we have to make an investment in these wells. They are not a cost, they are an investment. You're not going to get a permit to go back into an urban site where the neighbors are up in arms because you're drilling in the first place. I mean, heck, it's hard enough to get a permit anywhere right now, at least here in the Southwest, simply because of groundwater issues. But you've got to take a look and stringently go and stress that a water well completion is an investment. So that means the best products possible. That means the best applications and anticipation, from the casing to the grouts, the cements, the gravel feed to everything. It has to be looked at as, is this sucker going to last not 25 years, but 75 years? And with the proper application, with a little bit of work, you can anticipate water chemistry and then dial in the materials accordingly. But you've got to make that investment.
And you know, I mean, when you look at asset management angle of things, the EPA still cites 40 years as the expected lifespan for asset management purposes for a water well. But you're exactly right. We're looking at water wells, 75, 80-year lifespan because, with municipal well costs, approaching $2 million in a lot of cases. Or more, that is a huge investment. And, you got to look at those things, and I had Marvin Glotfelty on the show last year, and he talks about life cycle costs. That was, really the subject of his McElady talk.
On that.
Yeah, and it really is true. I'm a big believer in that, and it's kind of like making these decisions right up front where you're going to have a well that will last that 75 to 80 years. It may outlast you, but I tell people that if you do stuff like that, they're going to hang your picture in the boardroom as a hero, and you're going to be remembered fondly as setting themselves up for the future. So, comments on that?
It's just setting a precedent wherein the out of sight, out of mind mentality where we'll be able to replace these wells in 20, 40 years, it's no longer viable. We're just not going to be able to do it. So we better put our best foot forward, do the very best we can. And that goes for transmission lines and everything accordingly. The structures that go around the well. You're going to have to work on these wells. I recently had an operator, proud as heck of his operation, built this god-awful or gorgeous, if you will, monstrosity around the well, and I said, where are you going to be able to service it? Oh, that's a brand new well. We're not going to worry about that for years. Well, sure enough, the pump failed, and he's pulling the roof off of that structure, and I happen to be back on his site, and I said, well, how's that working out? And he goes, oh, that's costing me a fortune. So yeah, don't build structures around wells where you think you're never going to have to service that well. You're going to have to service that well. And if you don't service that well, it's going to embarrass you at some point in time by failing when you least want it to fail. So, yeah. And that's we're going to hopefully talk about well rehab later, but that's, you got to plan for that. I mean, most people do not plan for you got a new well, you don't even think about rehab, but that's an important part of that life cycle cost is planning for those things on regular intervals. And that's something we talked to Mike Schneiders about, so go back and watch that show. For anybody that's watching here, is understanding how long your well takes to get to that point where is the optimal time for well rehab, but you got to be able to get access to the well to do that and make it easy. Design it for maintenance. excuse me for interrupting, but Tom, this industry is run to failure. I get calls repeatedly wherein my production's off, or my wire to water's off, or I'm in a situation where I'm out of water. Running to failure is not a viable option. A case in point is we've done presentations with the city of Berlin. The city of Berlin has got two major rivers, or one major river running through it, but they're not relying on groundwater. Excuse me, they're not relying on surface water, but on groundwater. They've got some wells that are in excess of 120 years. They have some redwood wells. They have some old wells. But, true to the nature of the Germans and how methodical they are, if they see a decrease 10% in well efficiency, they pull the well. They start looking at, is it a mechanical, is it physical? What are the earthly environments that we're up against that would deem this well to now be, requiring some attention? If I could only get people in this industry to look at something at 25%, we could save ourselves a tremendous amount of time and money. But again, the whole industry is based on run to failure, and it's a travesty from the simple standpoint. A good deal of our infrastructure is that. We see pipelines failing, we see bridges failing, because nobody's paying attention. And if it's a water well, nobody's paying attention because it's out of sight. So, yeah, that's where we come up.
Yeah, out of sight, out of mind on the water wells. That's for sure.
Yeah.
And yeah, not going to be my responsibility because but I had a site in California. They're it was a little nonprofit camp for blind kids. Their MO was they drill a new well every 10 years because the well would run out of water and quit pumping, so they just go out and drill a new well. Well, that seems a little like a pretty short time span. We went in and looked at it, and they were basically getting some really heavy iron bacteria plugging going on. And so instead of drilling a new well, you just go in and clean it out and
train it accordingly.
Yeah, so they were like going for their fifth well, and it was just crazy. So it's thinking these things through, and I call it, I've got a little program I do, for my clients called systematic well management, and the whole design concept, you design, construct, there's like 10 phases all the way through decommissioning the well, but the middle part is really that diagnostics and maintenance and, and working with Mike Schneiders to kind of diagnose what's going on with the well and keeping it basically, the optimal well performance plan is what we call it.
Viable. Yeah.
Yeah, and it's like a little handbook, to maintain the well. So
there's a book that both Mike Schneiders and Tom Hanna published a couple of years ago, and published by the National Groundwater Association, The Life Cycle of the Well. It's extremely valuable reading because it does give you the indication that no different than the gray hair you and I both possess and the issues we're all facing. We're in a maintenance mode of, if things are getting older, things are wearing out, we're going to have to go ahead and find ourselves a better warranty plan. So the life cycle of the well, or the reality that what you're facing is in fact an operating viable asset. I tell a lot of operators, I said, if you stay in a well, if you check the water chemistry periodically, look at your static water level and your efficiencies, your wire to water, you won't be embarrassed. And what typically happens is when a well fails, you then have to go in for an emergency meeting before your water board and say, we didn't anticipate this. This is something. And if you have that, then you do get embarrassed and you do look like you're not taking care of business. However, if you make a line item in a budget and say, we're going to put $100,000 a year towards well maintenance and well testing, well, then all of a sudden it's an accepted practice. And those are the kind of changes in thinking that have to come about for people to recognize that you don't want to be embarrassed, or you don't want that well to go down in the middle of the summer. Yeah. There's a water agency that's going to have to increase their rates another 30% in the next 3 years because their maintenance has now taken to such an extreme that that's what they're operating with. And guess what? The ratepayers aren't going to be happy about that. They're going to say, well, why didn't you anticipate this? Why is this now coming to a head? So, yeah, there's a lot of things that have to be addressed. But the simple fact is that if you put line items in your budget and anticipate maintenance, you probably will be rewarded with some streamlined operations and benefits at the end of the day. You'll look more like a consummate professional.
Great point. And I will say that, in working with asset management plans for small water districts, the one thing, I mean, they talk about valves and life cycle, and, critical failure points and all that type of stuff. But the one thing I commonly do not see them putting in there is well rehab costs and building that into their capital improvement plan, their CIP. And it's generally not there. So you all of a sudden get caught by surprise when your specific capacity is at the point where you need to rehab and we don't have the funds available. It should be in your capital improvement plan. And often with small water districts, I don't see it there. You got all the valves and all that stuff you're talking about, but the well is almost like a kind of off here by itself. So
they are, for some strange reason, unlike anything else mechanical or an operational asset, they're somehow immune to ever needing attention, and that is not the case. And it will, in fact, eventually come up and bite you. It'll bite you in the wallet. So.
It will, because we know when wells fail, it's never during the middle of the day. It's going to be 3 a.m. on Christmas morning, right?
Nights and weekends, and it's usually rain.
Yeah, exactly. Yeah. So, which is going to cost you. It really is. Yeah. Emergency repairs like that are going to cost you. So it's really, I'm always astounded that that's not built into these asset management plans. And so that's
well, and then we can get into efficiency as well. I mean, I will oftentimes talk to a water manager or an operations manager, and he'll just say, "This is fine, everything's working good." I'll go across the hall and talk to the guy who pays the electric bill and ask him, "Hey, if we could get you a more efficient completion, if we could save you 20-25%, what would that be worth to you?" And so efficiency becomes an issue as well. By going in and doing upfront, doing the most efficient open area completion possible is going to pay off in spades right off the bat, but it's a return on investment that continues. And then at that point where in fact you need well rehabilitation, again, that cost up front is going to go ahead and warrant a savings in the long term. So but you have a hard time getting people to accept that, and it's a paradigm shift that's going to have to be addressed sooner or later. Yeah.
Well, that's an interesting point. That goes back to the most efficient well design too, getting the screen and gravel pack right, because that's going to affect your pumping costs. A more efficient well is going to cost you less electricity to pump. So, it's and I often don't see people factoring that in either. It's another one of those things that people don't think about, but electricity costs aren't getting any cheaper. That's for sure.
Well, and it's interesting. 10 years ago, we were hardly getting any traction, but that was electricity costs were 40% from back then than we are today. So you're not going to see energy costs coming down anytime soon. So you better be looking and designing the highest efficient well completions you possibly can, and designing with the best possible materials you can for, again, not an efficient operation, but long-term viability and efficiency. So.
Right. And in the long run, as Marvin Glotfeldt says, the way to look at a well is what it costs you in the end, not the upfront construction cost. The cheapest well, upfront probably is not going to be the cheapest well over its lifespan.
No. Well, I mean, you get what you pay for, and conversely, you don't get what you don't pay for. And you may very well have some cost savings up front, but you're not going to see those long term. And that is not going to bode well if you can't get back onto the same job site or your transmission lines have to be moved. So,
Exactly. So, man, hold on just a minute. I'm trying to seem to be having some. Okay, we're good. I was just looking at my YouTube broadcast. having some challenge. I was having some challenges earlier getting connected. So let's talk a little bit about now that we got the well constructed and we've talked about best management practices. Let me look at my notes here, but the challenges of effective well development, and as you and I were talking before the show, is this is an area that is chronically ignored, underbid, and you really don't, if
maybe not even bid.
Yeah, or not even bid. And I always tell people that if you're going to get a change order for a well construction, it's going to be for development, and you probably want to look seriously as that, and because it's always underbid in my, if it's even bid, and so you and Mike Schneiders have done some work on this, and maybe you can talk a little bit about the problems you're seeing and how we resolve some of those problems, and even why well development is so important. When we get back to efficiency of the well development is a crucial part of that. So dive in on that.
Well, Mike Meemer, our former sales manager, just passed away back in December. Mike was a huge proponent of well development. This is going back 20, 25 years ago. And his standard MO when describing the subject was, it's a hole in the ground until you develop the well. And it's no more true today than anything else. What Mike and I published back in April in the cover article for the National Groundwater Journal was something we'd been seeing for the last few years, and that was an operator would go in and quote-unquote develop up the well and then move off. And during the drought, which we experienced to severity, which you're well aware of, the last 5-6 years ago, we were seeing all kinds of folks coming in. Folks that had no business drilling competent wells for ag operators, for some municipalities, and the motivation was get a hole in the ground and then move off. And so within a matter of months, we started getting videos from various pump installers and stuff saying, what do you think's going on? And there was mud coming through the screen. And these were wells that were supposedly developed up. So we started looking at, well, was there any incentive to develop this well? And 9 times out of 10, the program, or if it was an ag operator, he just wanted a well and he wanted something to come out of it that looked remotely like water. So there was never an incentive. There was never a reason for anybody to take the time to develop up these wells. So we started looking at it from a standpoint, it's a common practice in light of a drought. And I would argue to the audience, if by chance you've got one well that is just not performing, take a look at when it was drilled. That right there is sometimes a single key ingredient in regards to the total mix of what has happened. If there was no inducement, if there was no incentive to develop that well, then it probably wasn't developed properly. And if not, then you got an opportunity to go back in with a mud dispersant. And we've had successes going back 40 years on operators that said, hey, I've got a well, it's never performed, we've acidized, we've chlorinated, we've never seen any change in production. And this was a one-off. This was a well that was in the middle of a field that had viable production of 2,500 to 3,000 gallons a minute, big wells. And this one was plugging on 700-800 gallons a minute. We provided some of our mud dispersant, the Johnson product, the 220, and he called me up 2 days later and said, that stuff's a miracle in a bucket. And it just goes to show that you can successfully develop up a well that's 40 years old if by chance the care and love has not been given up front. And that's what we're arguing today. What Mike and I published was a study of changes that we're seeing in the drilling fluids, in that there's a movement wherein, no different than the gravels that we've got, and no different than our subject matter a little earlier with supply chain issues and such, we're seeing some changes in regards to the raw material. And I think in anticipation of what was going on, that there were some additions of polyacrylamide, some of the polymers that were going into the mud systems. And I don't fault anybody for having to go ahead and change the formulation if the product itself is in fact not, if your raw product is not meeting the rheology and the kind of material requirements, then some polymers were probably warranted and required. But what we were seeing was that more than what we had originally anticipated were were showing up, and this is across the board. I mean, I just found some product a couple of weeks ago in one of my distributors' facilities. I got a bag, I sent it off to the lab, and sure enough, we found an inherent amount of polymers in it. So the sole reason for our paper was not to, in any way, shape, or form, discredit any mud supplier. It was just simply to go and let a lot of people know that, hey, there are some polymers in there, and a mud dispersant is not going to take care of that. So you're going to have to go back in and superchlorinate. The well's going to drill as the well has always drilled. You'll get a fine completion in regards to your borehole stability, your skin, or your filtrate. Everything there will be competent. But when it comes to eliminating the mentality of it being a hole into a well, we are advocating going in with superchlorination, anywhere between 1,200 to 1,500 parts per million for 12 hours, agitating, swabbing that in, because if you believe that there is some benefited polymer in your mud system, you've got to treat the polymer before you can run any mud dispersant. I don't care whose product it is. There's 3 different suppliers of mud dispersants out there. 2 of them are almost identical, and of those, they're not going to work against another polymer. So you're going to put yourself in a situation where superchlorination is becoming a factor of just simply having to go ahead and properly initiate your well development. And that simply means 1,200 to 1,500 parts per million for 12 hours with agitation, and that will remedy the situation. It's a single step that just needs to be addressed to go ahead and get us back to where we need to be in regards to properly developing up, getting that full mud system out of the well, so we've got the proper communication to the formation through the gravel pack, and a more efficient, more viable well completion. So yeah, I have nothing with concerns for the mud companies. They're doing exactly what they're doing, and they're doing it because they need to, and that's fine. It's just that we saw nuances where we needed to address from the standpoint of that extra step, and I don't fault them, but we're trying to go and recommend an extra step of superchlorinating to go in a remedy or take care of some of these issues.
Do you recommend doing the superchlor? I mean, obviously, and in my experience, the polymers do not show up on the MSDS sheet, so there's really no way of knowing unless you ship a mud sample off to the lab, at which point it's too late to really, for your well development. So do you recommend just doing the superchlorination just as part of your SOP for well development?
Yep.
So. Yep. And it doesn't hurt anything to superchlorinate it. It's just a little bit of extra expense and time, which is probably well worth it. 12
hours. Yeah, it's an additional 12 hours of rig time, but it will pay off in spades. I'm quite confident. So, but yeah, that article got a lot of traction, got a lot of people upset, and it was never our aspirations or considerations to offend or upset anybody. We just wanted to go and state that what we're seeing in regards to field practices today have to be augmented with the simple fact that we're seeing polymers being added. They're not necessarily being advertised. I recognize and fully understand their need, but we also have to acknowledge the fact that a well development is critical, and if there are polymers, the only way to get those polymers out is to superchlorinate. And I want to be really clear, the 1,200 to 1,500 parts per million is not part of the disinfection. The disinfection still has to come up at the end of your well development, but that's going to be done at 200 to 300 parts per million. So don't confuse the 1,200 to 1,500 parts per million as part of disinfection. That simple step is just to eliminate and eradicate the polymer. Then you go in with a mud dispersant. You do that as standard practices, as what we advertise on our YouTube videos and such, and then you turn right around and put yourself in a prospect of disinfecting the final completion, the final well. So.
Okay, yeah, so yeah, that I totally get that. And it's interesting that you get that kind of negative reaction because things change in the industry, but people want to, and the formula, and like you say, there's really nothing the matter with it. It's just we need to understand it and adapt our well development techniques, and change them from what we've been using for the last 40 years to account for that, and we can deal with it. So
we're losing good gravels. I mean, all of these naturally mined materials are finite, and we're not finding more or less better quartz deposits were certainly, challenged from the standpoint of trying to find some of the bentonites. We tested a bentonite, as I mentioned a couple of weeks ago, that comes here from the Southwest. Well, it has the same kind of rheology that you would have with some of the premium Wyoming bentonites, but it only comes at the prospects of adding these additional polymers. So yeah, you just need to know they're there, and you need to address them accordingly. And I'll reference that we've done a best practices on a lot of QR codes now. This is actually a hard hat sticker that I developed that
Nice.
given anybody who's interested, but it has all of the YouTube videos on procedural practices on acidizing, chlorinating, and mud dispersants. So if somebody has a question in the field, and they're now in English as well as in Spanish, that how do I mix up the mud dispersant? What do I do if by chance I suspect I've got benefited chlorine? It's all in these 7 to 10 minute long videos. And if anybody's interested, just give us a shout and we'll be happy to send you some. But they go well in the doghouse, they go well in a hard hat. And that way you eliminate the excuse of, oh, I didn't know how to mix this up properly. It's like, oh, you do. It's on your hard hat. Just put your phone up to it.
So maybe you can send that to me via email, and I'll post it up too, so we can get it out to people, because that sounds very useful. So what else do you see on well development? Usually it's the time, and I usually put in specs in my drilling specs that I write for meeting turbidity, specific capacity requirements. Is that a common practice in the industry to, how do you know when well development is done? That's really kind of a best management practice. Yeah.
Well, it comes down to practices. A lot of operators will simply go ahead and, once they've cleaned up the well, once they think they've got the screen and such all satisfactorily cleaned, they'll just run a pump in, and they'll just pump the well, and then they'll rawhide. Term rawhide being turn the pump on, turn it off, allow the column of fluid to fall back in. That's fine, but that hits the high point. That hits the most efficient screen interval. If a true development practice needs to be applied, it needs to go from the top to the bottom. If it was worth screening, it's now worth spending some time developing. So going in with your mud dispersants, initially going back in with your chlorine, then once that's done, then you can add the mud dispersant, move that mud dispersant across every interval, every screen section you've got, give it its 15 minutes of fame, and then at that point in time, go ahead and pump and see what you get. And if it doesn't respond, your program should have additional hours for additional well development. So a lot of operators will put in a standard 40 hours. My standard joke is, and I think it's funny, but nobody else does, is that, oh, you know what? The well did not read the program. It didn't know that it was supposed to come clean in 40 hours. So you have to take that into consideration. You have to look at it from the prospects of, yeah, we're going to have to put some additional hours into this thing to make this well as viable as possible. But your turbidity, your overall net production, your sand production, what's coming up from a Roslyn sand tester, all of these have to be taken into consideration. But you cannot think that 40 hours is that golden rule. 60 hours may not be sufficient. And you may have to treat some wells twice. I've had certain circumstances where a guy says, hey, I've used your mud dispersant, got it clean, but it's not great. Oh, okay. So what are you going to do? He goes, well, I don't know. And I went, well, how about a second treatment? Why not put another $150 to $200 worth of chemicals down there, swab that in, and see? He calls back, he goes, I'll be down. He goes, that really cleaned things up, but I still got a problem. And sure enough, it took 3 completions to get where he needed to be from the standpoint of the NTUs, the turbidity counts to come down, and the efficiency to be there. So once is not always enough. Sometimes twice isn't enough. But yeah, having a set amount of hours for standard development is great, but then anticipate the fact that, yeah, maybe a second treatment is warranted. And you know what? Again, the well hasn't always read the program to find out exactly where it needs to be. So you go from there. But anticipate that. You have to anticipate. If you put it in the program, you'll never need to use it. 40 hours will probably be more than sufficient. But if you don't have it in there, then all of a sudden you've got an adversarial situation where the contractor's saying, hey, we're done. We've met all the obligations. And yet they both the well owner and the well driller recognize that, yeah, we're not done. So if you put the additional hours in there, you probably will never need it. And it's like anything else. Anticipate. If you got it on the job, if you got it on the job site, or you got it on the shelf at the shop, then you're probably good. But if you're anticipating something coming from Houston, then yeah, you probably will be disappointed. You'll have some downtime. So putting it in the program is extremely viable.
Yeah, and I understand with well contractors that they're bidding on a project. So if they put in a lot of hours for well development, that may be the difference in the bid price. So you run into that challenge as well. But it's like we say, when it comes to well development, you're done when you're done. It's not a set number of hours. So
well, and if you do put in 40 hours, 50 hours, whatever that magic number may be, then you've at least got a standard bidding. But then you want to go ahead and put in additional hours that are not part of the bottom line, so that there is in fact some negotiation that can ensue. So yeah, it's just, if you anticipate what might happen, you probably have got it nipped in the bud right there. But you have to have that. You have to have the confidence that you have got the additional hours in, that you're doing the very best practices. Then when you're done, you go into bottom, you circulate clean to bottom, you come back out, and then you video that well. The one thing I'm finding that's so incredible, that operators are oftentimes not doing a final pass at videoing the well and the completion. It's almost like, yeah, well, we've completed it, but we really don't know what we've got. Video that well, hand it to the client, then install the pump. That way you've got a base mark for moving forward. If there is in fact an issue with a hole in the casing or mud coming through, then you've got some negotiating points for a later date. But that video is critical. So it's a CYA. You run that for your own confidence level, but you also run it from a standpoint of giving it a baseline, so that the next operator, the pump installer, whoever, can come back in and see whether or not has someone dumped a bunch of 4x4s down the well. Who's responsible if you don't have a video? And those videos, I've recently heard that somebody's come up with a portable video that's less than $1,000 now. And there's just no excuse not to have a video camera. Even if you're going back into a well that you didn't drill, that you're just rehabbing, video it before you get into it, because that way at least you've got your baseline as to the conditions and the circumstances that you're addressing, to make sure you cover yourself. This is a litigious society. You want to make sure that you've covered yourself.
Yeah, and I always recommend video before and after, and it protects the contractor too, so they can't have claims coming back on them when you got the video evidence that it's been done right. So
the customer, the contractor, the pump installer, it covers everybody, and it just gives everybody a baseline and an understanding of where we are. So and cleaning the bottom is always critical. I don't care if your well rehabilitation is going smoothly. Once you're done, clean the bottom. Once you develop a well, clean the bottom, because that becomes a food source for bacteria. That becomes a plugging agent for later considerations. So clean the bottom, make sure the well is as in good a shape as humanly possible before you return it to production.
Finish the job. Yeah, we see a lot of unfinished jobs. We'll just leave it all down there. There's a sump down there. We'll just leave it all down there. Nope, don't do that. So, all right, what we're probably not going to get to the well rehab. So I'll ask you to come back on at some point to do a part two. But one last question is, what are the pros and cons of bringing in a specialized well development contractor, at least to do part of the work? I'm talking like somebody like WellJet, Charlie Carter there that I know you've worked with. Shout out to Charlie, he's a great guy. What are the pros and cons of bringing in somebody specialized? Because I have found sometimes drillers, and we get back to the whole underbidding thing, drillers would rather be drilling, and well development is just that they get bored to death with it. And that, I think that's sometimes where it gets shortchanged a little bit too. So I have found sometimes bringing in somebody just to do the well development is that specializes in that is an advantage. So what are your thoughts on that?
Well, I would even go so far as to say, no different than the medical industry or any other professional, you better know what you're going after first before you start calling in professionals. And that would mean if you've got a medical situation, you're going to get some blood work done. You're going to get an analysis done of what are the conditions, where am I with my my blood cells in the situation there. Getting some lab work done is incredibly valuable. This is going to be a shout out again to Water Systems Engineering and Mike Schneiders, but two of us, Tom, you and I, can be standing over a wellhead. We can both imagine with some confidence, with experience, of what's going on downhole. But until you've actually got some water analysis and maybe a scale sample or whatever there might possibly be that we can garnish and get off to a lab, you and I are both speculating. And that speculation can be extremely expensive if we're both off. So the consideration I always argue is spend a few $100s to get some lab work done. And the nice thing about specifically the Water Systems Engineering is no different than going to a laboratory that says, oh, you've got a problem, your water chemistry's off, or you've got a problem. The differentiation is that Water Systems Engineering is going to tell you the remedy. They'll tell you the procedural and the process in which you need, and that can go right into a bid document. So now all of a sudden you have, if you've taken the time to go ahead and set up, and what I'd recommend is oftentimes if you've got a major well field, test all of your wells. You can get those done very cost effectively. You then take that report, you put it in a file, and when that well goes down, you pull that file back out and you say, oh, that's right, we had iron bacteria, we had some pseudomonas, we had these that we needed to address. You don't have to go through the whole bidding process and analysis. You've literally got a track record ready to go there. And as a result, you can go ahead and bring in your Charlies of the world and your other accomplished, very capable well rehabilitation specialists to go and treat that specifically while you're waiting on the pump to be repaired or waiting for a patch to be installed. But having the lab work done is no different than in the medical profession having the blood work done, knowing what you're going to treat. And again, I've got 36 years experience. I can look at a video and say, yeah, this is probably what they're up against. But I can be wrong. I can easily be wrong, or there can be more to it. And so having that lab work, having that process, the procedures put in place will save you an awful lot of time and effort. And as we both know, mobilizing equipment can be prohibitively expensive. So get the lab work, put it in a file, or anticipate what you're going to need, and then you bring out the professionals. But you're right. There is no different than any other industry. There are professionals that are segmenting their way into well rehabilitation, high pressure jetting, any of those type of practices, as opposed to just drilling a well. And so a lot of contractors are diversifying, or a lot of them are in fact, fine tuning their work to specifically well rehabilitation. But getting that knowledge of what you're going after first. Is it something I can just treat with a simple dosage of either acid or chlorine, or is it really something I need to go ahead and a mud dispersant, oftentimes, like we talked about, if the well is not properly developed, they'll see that in a water analysis and go from there. So getting the lab work done, I think, is critical, but then bringing the professionals on, having a contract and having a couple of bidders go after the work will make it that much more viable.
All right.
Did that answer the question?
I think so, and we're kind of at time now because we could probably go forever on this topic, and I'll get you back on in a few weeks if that works to talk specifically about well rehab, because I know you got a lot to say about that and we just can't squeeze it in here. So I got your contact information here, and there's your web address and your email, and so that's how people can get a hold of you and contact you about your videos too. I mean, those best practices, I think those are great. Yeah, and if you'll drop me a line with those, I'll put those out there for folks too. Thanks so much for coming on and sharing your wisdom. And like I say, we'll get you back on to talk in a few weeks to talk about the well rehab, do a part 2 here, and hopefully LinkedIn will be a little more cooperative. We had problems with that today, but thanks, Ed. And
my pleasure. I enjoyed it.
Yeah, we'll get you back on in a few weeks. I will. We'll close out here, and we'll talk to you later. Thanks, Ed. All right, so that was part one. We did not get to well rehabilitation, but we'll get Ed back on here in a few weeks, and I really thank him for coming on and sharing his knowledge. He's got so much he can share, and I really appreciate it. That is the show for today. We will be back next week, hopefully with the new show. And thanks for tuning in and listening. Like, comment, share. We love your comments, and I try to respond to everything. We will see you next week.